Now we have part 2 of 1-5 solving inequalities. And this part we are going to be talking about compound inequalities, which are two inequalities joined with the words and or. Let's start by looking at how to solve an and inequality. We are on example 7 right now since this is still a continuation from 1-5, the first part. So if you notice right now we have two inequalities. We have 5 is less than 3x minus 1 and 2x is less than 12. So you're going to solve these both separately and then use them to create your answer at the end. So to move -1 to the other side, we add 1. So 5 plus 1 is 6, which is less than 3x. And then we have to get rid of that 3 that's touching that x, so we divide both sides by 3. Now remember, you divided by a positive number, so it should not change your inequality sign at all. So that's going to give me 2 is less than x. It's helpful to bring down the word and, because that's going to help us answer our inequality later on. So now we move on to the one on the right. To get rid of the 2 that's touching the x, we divide both sides by 2, and I get x is less than 6. Okay, so this word and means that both inequalities have to be true. Okay, so let's plot these on a number line. So we start with our x and we read towards the number. So this reads x is greater than 2. So since it's just greater than, it gets an open circle. 0 is not greater than 2, so I should shade everything on my right hand side. Now let's move on to the 6. So x is less than 6, so I'm going to plot 6. Again, it's an open circle because it's just less than. 0 and 2 are less than 6, so we need to shade everything to the left. Now, from -infinity to 2, are both inequalities true here? No, only one is true here. Okay, from 2 to 6, are both inequalities true here? Yes and yes, there's 2 lines. And then over here on the right hand side, from 6 to positive infinity, are both inequalities true? No, there's only one, so you should shade in the middle of 2 and 6. And that's your answer. Okay, everybody, press pause so you can try example 8, and remember the word and means you're looking for where both inequalities are true. Okay, let's start with our inequality on the left-hand side. To move -2 to the other side, we have to add it to both sides. So that leaves me with 4x is less than or equal, and then 6 plus 2 gives you 8. Now to get rid of our 4 that's touching our x, we divide both sides by 4, and so you get x is less than or equal to 2. Bring down the word and because it's going to help you answer your inequality at the bottom. So now on my right hand side I have a parenthesis, so I need to distribute my 3. So 3 times x is 3x. 3 times 2 is positive 6, and then you bring down your greater than, you bring down your x plus 3. So now, if you notice, you have x's on both sides of your inequality. So I like to move the smallest x, and since it's positive, we're going to subtract it. 3x minus x gives you 2x. Bring down the plus 6 is greater than 3. Now, since my variables are on the right hand side, I now need to move my positive 6. Since my variables are on the left hand side, I need to move my positive 6 to the right hand side. So, to move positive 6, I'm going to subtract it. And that gives me 2x is greater than, and then 3 minus 6 gives me -3. Divide both sides by 2. Again, since you are dividing by a positive number, there's no reason to switch your inequality. So that leaves me with x is greater than negative 1.5. So let's draw these on our number line. I have 0, 2 is to the right of 0. If you notice, it's less than or equal to, so it should get a colored in dot at 2. And then you should start with your x and then read towards your number, so it reads x is less than or equal to 2. So 0 is less than 2, so I would shade everything on my left-hand side. So now negative 1.5 is to the left of 0. And if you look over here, it's just greater than, so it is going to get an open circle. 0 is greater than negative 1.5, so I would shade everything to the right. Now, in this region, are both inequalities true? Nope, just one. In the middle region, are both inequalities true? Yes, they are. And then on the right-hand side, are both inequalities true? Nope, just one. So you would just shade in between negative 1.5 and positive 2. So now we are going to move on to solving and or inequality. So let's look at example number 9. So we have 7w plus 3 is greater than 11, or 4w minus 1 is less than negative 13. So we solve our two inequalities separately. So to move positive 3 to the other side, we start by subtracting it. So that leaves me with 7w is greater than, and 11 minus 3 gives me 8. Now to get rid of that 7 that's touching that w, we divide both sides by 7. So when you divide by 7, it doesn't go in nicely, so you can leave it as 8/7. Or if you like a decimal better, you could have written 1.14, something like that, enough that I know that you got the right decimal. Bring down your word or, because that's going to help us answer our equation. Now let's move on to our inequality on the right-hand side. So since it's minus 1, the opposite of minus 1 is plus 1. So bring down your 4w. Bring down your less than sign. Negative 13 plus 1 gives you negative 12. To get rid of that 4 that's touching that w, you have to divide both sides by 4. Again, guys, when you're dividing by a positive number, it does not switch your signs, only a negative number. So, negative 12 divided by 4 gives me negative 3. So now, when we are answering this question, the word or, either inequality must be true. So let's draw our number line. So 0, 8/7 is positive, so it should go to the right-hand side. Or if you put 1.14, same thing, it's going on the right-hand side. And then since it was just greater than, it gets an open circle. So now, is 0 greater than 8/7, or is 0 greater than 1.14? No, so that means I would shade everything on the right-hand side. Now, negative 3 should be to the left of 0. Since it's just less than, it is also going to get an open circle. Is 0 less than negative 3? No, so I would shade everything to the left-hand side. Now, let's look at our number line. Is one or the other inequality true here? Yes. Is one or the other inequality true here? No. Is one or the other inequality true here? Yes. So on your number line, you should have everything to the right of 8/7 colored in and everything to the left of negative 3 colored in. And that's your answer. This is your last example, guys, so go ahead and press pause, get an answer, and then press play to see if your answer matches with mine. So I'm going to start by solving my two inequalities separately. So to move positive 1 to the other side, I'm going to subtract it. 16 minus 1 gives me 15. Bring down everything else. To get rid of the 5 that's touching the x, we divide both sides by 5. And so 15 divided by 5 gives me 3. Bring down my word or because that tells us how to graph our inequality. Now let's move on to the one on the right. So to move positive 9 to the other side, we are going to have to subtract it on both sides. So that leaves me with 3x. And then 6 minus 9 gives me negative 3. To get rid of the 3 that's touching that x, divide both sides by 3. So x is less than negative 1. Now let's draw ourselves a number line. Remember, or means either inequality is true, 0. 3 is to the right of 0. Now you read starting with your variable, so x, and then if you notice, look, the big part of the arrow is touching the x, so we read it as x is greater than 3. So it's going to get an open circle. 0 is not greater than 3, so I would shade everything to the right of 3. Now negative 1 is to the left of 0. This is written like you normally see it. X is less than negative 1. Remember, it's less than because the smaller part of the arrow is touching the x. So it is also going to get an open circle at negative 1. And then if you think about it, 0 is not less than negative 1, so that means I would shade everything on the left-hand side. Now let's check each part of our inequality. Is at least one of the inequalities true over here on my left-hand side? Yes. Is at least one of my inequalities true here in the middle? Nope, there's nothing. And then to the right of 3, is at least one inequality true? Yes. So you would shade to the left of negative 1 and to the right of positive 3.